We talked about the electrochemical cells, the electrolyte, the two electrodes, the cathode while the reduction is happening, the anode while the oxidation is happening, and we also talked about the features for electrochemical reactions such as the separation of the oxidation half-cell reaction and the reduction half-cell reaction, or the cathodic half-cell reaction versus the uh, anodic half-cell reaction. Okay, and we also talked about the transition between electronic conduction in the electrode and the ionic conduction in the electrolyte. Now we are going to introduce additional concept, including open circuit and the equilibrium cell potential. So again, let's still use the example of zinc and copper metal inserted into solution, electrolyte solution that contain zinc chloride and copper chloride. Okay, and sometimes people also put a ionic permeable membrane between the two electrolyte. We'll talk about the membrane in greater detail later. But anyway, this is an electrochemical cell, and we say that without applying an external power source, which means between the two electrodes, you do not apply an external power source, just between these two. And when the external circuit connecting the two electrodes is open, which means the external resistance essentially goes towards infinity. On the open circuit condition, all the external resistance goes towards infinity. As you can learn in physics, the external circuit current would be zero because it's open circuit. The resistance is infinite. There can be no electrical current or electron flow through the external circuit. Okay? Under this condition, if we can assume a few additional conditions, or if we can make a few additional assumptions. First one is reversible reactions at both electrodes. Reversible reaction, we'll talk about more about this later. But essentially, reversible means the reaction is at the same rate forward and backward. Reaction at the same rate forward and backward. Giving out the electron and taking electrons. If the reaction is at the same rate for both the anodic reaction and for the cathodic reaction. That's the first assumption. The second assumption is there is no internal electronic leakage through the electrolyte, which means this solution here, for example, does not allow electrons to go through it, which is an idealized electrolyte that does not allow electrons to internally short the two electrodes. This is the second assumption. The third assumption is only a single electrochemical reaction occurring at each electrode. For example, at the zinc electrode, that's only the reaction between zinc metal and the zinc ion, while at the copper electrode, that's only the reaction between copper ion and copper metal. If we can make these three additional assumptions, and if the external circuit is open, meaning the external resistance goes towards infinity, then under this condition, we would kind of reach so-called equilibrium condition. We would also say the electrochemical cell reaches equilibrium, which means the electron doesn't flow one way or the other way continuously, which means the zinc does not continuously get dissolved or the copper does not continuously get deposited or the other way. Okay, under this condition, we say the electrochemical cell reaches equilibrium, which means the forward reaction rate is the same as backward reaction rate. Under such condition, there would be a so-called reversible and stable potential established between the two electrodes, between the zinc electrode and copper electrode for this example. That would be, read to yourself, stable, which means it doesn't really change over time as long as you don't change the condition, including temperature, pressure, the concentration, and external circuit condition. Okay, there will be stable potential, reversible, we call it reversible potential between the two electrode, and such potential, people give it a name called equilibrium cell potential, sometimes equilibrium potential in short, EEQ. I give it a symbol of EEQ, E for potential, EQ for equilibrium. When do you get this? When you have open circuit condition and when the system satisfies these three assumptions: reversible electrode reaction, uh, no internal electronic leak through the electrolyte, and a single electrochemical reaction at each electrode. Under this condition, we can get a equilibrium potential, and this equilibrium potential would be, in this case, equal to the so-called open circuit voltage, or OCV.